On behalf of the American Statistical Association, it's my pleasure to welcome you to a discussion with Dr. W. Edwards Deming. This discussion is part of the American Statistical Association program for the filming of distinguished statisticians. This filming program is particularly valuable to our statistics profession insofar as it uniquely captures an historical perspective. The personal notes, expressions, feelings, and opinions of those who have contributed so much to the development of the theory and application of statistics. Our distinguished guest, Dr. Deming, is recognized worldwide for his contributions and achievements in statistical quality control. Dr. Deming's formal education culminated in a PhD degree in mathematics and physics awarded from Yale, and his early career was devoted principally to studies of the physical properties of matter while serving within several U.S. government organizations. During this time, he generated a strong interest in theories of measurement errors, the least squares principles, and the statistical sampling. His work and interest was markedly influenced by personal contact with Ronald Fisher, Jerzy Neyman, Walter Shewhart, and other notable contributors to the newly developing statistics profession. He has been, for 30 years, a consultant in statistical studies with practice worldwide. His clients are numerous and varied. They include railways, telephone companies, hospitals, and many others. He is perhaps best known for his work in Japan, which commenced in 1950 and sparked a revolution in quality and economic production. In December 1950, the Union of Japanese Scientists and Engineers instituted the Deming Prize to be awarded to individuals and companies annually for innovation and quality control. In May 1960, he was decorated by the Emperor of Japan with the Second Order Medal of the Sacred Treasure. He has received the Shewhart Medal from the American Society for Quality Control. He is the author of several books on statistical methods and over 150 papers. Since 1946, Dr. Deming has been professor of statistics at the Graduate School of Business Administration of New York University and has lectured in universities throughout the world. It's a pleasure to have you with us, Dr. Deming.
Thank you.
To facilitate our discussion, we have a distinguished panel of 3 statisticians who have been in various ways responsible for the development, teaching, applications, and publication of statistical quality control. These individuals are Dr. Churchill Eisenhart, Senior Research Fellow, Center for Applied Mathematics, National Bureau of Standards; Dr. Lloyd Nelson, Director of Statistical Methods, Nashua Corporation; Dr. Fred Leone, Executive Director, American Statistical Association. It's indeed a unique pleasure to have all of you gentlemen with us. Well, let me begin with a first question for you, Dr. Deming. And looking over your career and your training, how is it that you came to change so strongly your career interest from physics to statistical quality control?
The change was not abrupt, nor calamity of any kind. Remember that in physics and mathematics, one learns about probability, geodesy, about Gauss, about kinetic theory of gases, diffusion of gases, surveying, a theory of errors, the works of Helmert, for example, whose textbook I studied, preceded by 50 years the work of Student and a lot of the work done by Sir Ronald Fisher. There was lots to learn, of course, but I had a pretty good introduction to the subject of mathematical statistics and application of least squares. There was nothing abrupt about it. Naturally, I suppose I chose a path of least resistance, but I followed my interests and found many problems to work on, and here we are.
Well, we're glad you changed.
Well, there's no change.
Listen, Dr. Deming, during World War II, at your suggestion, short courses were given for and intended by many business executives, industrial executives, and management personnel, and many long courses were given for engineers and other people who were on the production line and able to use statistical methods. These courses, of which I understand that you yourself taught 23 and were attended by nearly 10,000 people from nearly 700 industrial firms in the United States and 13 from Canada. With this great World War II push for statistical quality control in the United States, why did the United States fail to become the world leader in post-war statistical quality control?
There are two reasons. In the first place, you spoke of teaching statistical methods to management. Well, that was something of a farce, because in the first place, we knew not just what to teach. In the second place, at the suggestion of Holbrook Working, who was 4 steps ahead of anybody, we devoted in those courses one afternoon to management, if anybody could persuade them to come. One afternoon was simply not enough. Professor Working had the right idea, but one afternoon exposed to some techniques accomplished nothing. Moreover, there are other reasons. Although 10,000 engineers took the courses and did well, and although there were brilliant fires here and there, nothing happened. Everybody that engages in statistical methods, or I suppose other methods, finds great successes in his work, short-term successes. Well, those happened, but there was nothing permanent. American industry is so far behind that we have to think of the earth changing. The the altitude of Detroit must rise 8 feet. The altitude of Chicago, of Cleveland, of New York, and so on must change. Small-term, short-term, brilliant fires, though they may amount to a great deal of, in terms of dollars, amount to a great deal, $800,000 one place, $10,000 another place, per year I'm thinking of, $5,000, and those advances, those accomplishments are not enough. Like, nothing will happen. Nothing will be observable by that kind of performance. That's what we saw in 1944, 45, and onward, after those wonderful courses and techniques. The management never got the point. I think it was not until Dr. Duran talked to management and taught management, the management of techniques, that people began to see what the problems were. Now, when I went to Japan in 1950, I made sure that not to repeat the mistakes of America. I was able to get the top management of Japan together in one session. No such thing has ever happened in America. At those sessions with top management in Japan in July of 1950, August 1950, they learned something about their responsibilities. I told them, for example, that Japanese products would capture the markets of the world within 5 years. They could not understand the basis for my confidence, but they beat my prediction by a year or more. My confidence came from their ability as management and from knowledge of the power of statistical techniques, and for other advantages that Japan possessed at that time. One disadvantage that they had was their well-earned reputation for shoddy quality, cheap but worth the price. They had to overcome that. They overcame it. Even last November, some of those men that listened to me in 1950 told me that, again, for the 10th time, they could not understand the basis in 1950 for my prediction, but I had basis for my confidence. They told me that they would be happy, they would have been happy at that time, were they only able ever to get back to the economic position where they were before the war. They would be happy if they could only accomplish that much. They had no idea that what I told them would ever happen to be true, that they could become prosperous, take their place amongst the prosperous nations of the world. They could not understand it, but I knew.
Dr. Deming, you've had the opportunity to work with many famous statisticians in this country and abroad. Could you give us some of your personal recollections of these people and perhaps indicate what you think their contributions were to statistical quality control?
Well, all statisticians have contributed, of course, but I had the good fortune to meet Dr. Eisenhart in the early part of 1928. I had the good fortune to work with him, to come to know him better perhaps than even anyone in the Bell system. It took me many years to understand what he was saying. He was not a good teacher. Some of the points that he made to me so laboriously did not come clear for 20 or 30 years afterward. But I ponder over great scholars, over what they say to me, and I try not to stop till I begin to understand them. The fact, for example, that there's a vast difference between the purchase of, say, 1,000 pieces of some material, a one-time purchase, that is one problem. But the problem of continued purchase of 1,000 pieces per week is totally different. I learned one must pay attention to the statistical control of quality. A company that has statistical control of quality can produce 1,000 pieces, and they will have the same distribution day after day, week after week. Moreover, they know their cost. And in this day of a new economic age, one cannot deal with any other production. The day is over when price determines business. That is, when business goes to the lowest bidder. Those days are over. We're paying the penalty now of that kind of philosophy. It doesn't work. I'm afraid I'm not answering your question very well.
Dr. Deming, on another question, over and over again, we get a clear and simple message in your writings. Namely, top management has to absorb some of the principles of statistical quality control and then adapt these principles to the American conditions. Is the message that straightforward?
The message is straightforward. I can tell you the 14 points that management must accomplish. We're in a new economic age, and management must take their position in it. It is not enough for everyone to do his best. At a session about 2 months ago with a company, the so-called middle management of a company, and I do not know what middle management is, I asked him, how is it that you go about the problem of achieving quality and productivity, and someone answered in response to my question, by everyone doing his best. Oh, unfortunately, that is not enough. Everybody is already doing his best. Efforts require direction, and it is the function of the statistician to apply that direction. It is not enough. The top management commit themselves for life to quality and productivity, and there's no other kind of commitment will do. They must know what it is that they are committed to. That is, what they must do. These obligations cannot be delegated. Mere approval is not enough, nor New Year's resolutions. High-level quality committees may now have a job description. There is something for them to do. Never again can anyone in management say that he knows not what to do. They have my 14 points, and they're clear, I think. There is now a theory of management for production. No one in a school of business can ever again claim that there is nothing in management to teach. Students in a school of business now have a yardstick by which to judge the curriculum that is open to them. Does it show some attempt to present a curriculum for today's problems, or does it show obsolescence? Obsolescence, by the way, need not be planned. There's an easier way to get into it. And I would say the School of Business and teaching of statistics has gotten into it without any planning at all. Paper profits, the yardstick by which stockholders and boards of directors often measure performance of top management, make no contribution to material living for people anywhere, nor do they improve the competitive position of a company or of American industry. Paper profits do not make bread. Improvement of quality and productivity do. They make a contribution to better material living to people here and everywhere. We are in a new economic age. Ways of doing business with vendors and with customers that were good enough in the past must now be revised to meet new requirements of quality and productivity. Drastic revision is required. The 14 points that top management must accomplish, cannot delegate, are very clear. Briefly, number one, innovation. It is necessary to look ahead 3, 5, 10 years at the product and service to be offered. Innovation requires faith that there will be a future. It requires investment in research, in education. The second point is that top management must adopt the new philosophy, a new religion. We are in a new economic age, and have been for some time. We can no longer live with commonly accepted levels of mistakes, defects, material not suited to the job, people on the job that do not know what the job is and are afraid to ask, handling damage, failure of management to understand the problems of product in use, antiquated methods of training on the job, inadequate and ineffective supervision. Those days are over. Management has a job. We now have a yardstick in my 14 points by which anyone may judge the performance of management. The people that work in a company may judge the performance of the management. The stockholders may judge. The bondholders may judge. The banks. The third point is the people that make critical parts for another company must learn and use process control by statistical methods. There is no other way to achieve economy. There is no other way to know what your costs are. There's no other way to do business. This means that purchasing managers, by the thousands, must learn statistical methods. Do you know how long that will take? On an emergency basis, it would take 5 years. How long will it take? Probably 10. Statistical control of the process provides the only way for anyone to build quality in, to know that it's there, and to provide evidence that it is there. Inspection is outmoded. No one can afford it. It is ineffective. Never did work.
Dr. Deming, let me insert another question in this framework. Alan Wallace, in his historical perspective on the Statistical Research Group, attributes a quote to you from 1942. And the quote is, "The only useful function of a statistician is to make predictions and thus to provide a basis for action." Now that you've had another 40 years of experience since making that particular statement, how do you feel about it? Do you care to revise it, or do you feel stronger about it, or what's your view on that particular topic now?
I can only repeat it and feel stronger about it. There's nothing new about it. There is no knowledge in anybody's statement except that it makes a prediction. For example, when you make estimates from a sample in an enumerative study in which you are in effect drawing chips out of a bowl, you are estimating the result of what you would get from the equal complete coverage of that bowl. That is a prediction, that if you were to make the equal complete coverage, or if you were to draw future samples, you would get results within limits that are calculable by statistical theory. Now, in an analytic problem, it is more difficult because we have no bowl, we have no stable cause system, but there is no use, there is no help in any calculation or statement or set of figures unless they convey a basis for prediction of what we will get in the future. That was settled long ago. Neither Dr. Schuhart did not start it. Nobody in our generation started it. Those are principles that have been known in the theory of knowledge for centuries. And by the way, the theory of knowledge is one of the studies that statisticians ought to know more about, and that people in business ought to know more about. And by business, I of course mean service as well as the manufacture of things that you handle.
Dr. Deming, as you said a few moments ago, the Japanese up before the 50s were known for their inferior products. How were they able to revolutionize their industries following your teachings?
Top management and the whole of Japan took hold of the job in 1950 and went to work. They could not understand the basis for my confidence, but they did not argue about it. They simply went to work. They learned methods of teaching, intensive courses for engineers, and was able to tell top management what they must do. I had in previous visits talked to their leading statisticians so that they knew what part they could play in the reconstruction of Japan. And there was the great JUSE, so known by its telegraphic code, Union of Japanese Science and Engineering, able to undertake education on a massive basis for management, for statisticians, for engineers, for supervisors, for everybody on the job. And quality control became everybody's job. As I explained, it is nobody's job, it is everybody's job. And one of the problems that existed here, which took place, which happened after the courses that Dr. Eisenhart mentioned, The reason why the fires died out is that so-called quality control departments took over the job in America. And that the quality control departments took the job away from the only people that could do anything about it, namely the management and the people that work in a place. Nobody else could do it. What happened is the quality control departments made charts, they filed them in drawers, and the people that could do anything about it never heard of the problems.
Dr. Deming, now that your teachings in Japan have become better known, still I might ask the question, why has American industry not followed these guides and adopted your methods?
Most of American management has no idea that anything can be done. They may not even know that there are problems. They certainly have no idea that there's any way to turn. They have no idea there's anything to be done. That is one of the problems, one of the obstacles. Another obstacle is the hope for quick results. Hope springs eternal. Hope for quick results springs eternal in the human breast. To quote Pope with apologies, they will call up and ask, could you spend a day with us and do for us what you did for Japan, that we too may be saved? And they go away in sorrow, because it is not as simple as that. That is one of the problems. They seem not to know that quality control means that top management puts themselves in a hospital forever and they'll never get out. They have a job to do, and my 14 points tell them what to do. They never again need to ask.
Dr. Deming, there are lots of statistical procedures and tools, and more of them are being invented every day. Can you give us some idea of what you think are the effective statistical procedures for controlling product quality and thereby increasing productivity?
All statistical theory, I think, has uses. I've never learned anything to understand it, learned it well, but what I wouldn't find use for it the next day. But to answer specifically better your question, there are many methods that are necessary which are not being taught. That is, not being universally taught. There's nothing takes the place of a chart, just a simple run chart. Just plot the data in order of time, in order of production. One may one may use an X-bar chart along with a range chart. One may use other kinds of charts. So many people think that they have quality control if they have lots of data. They would come with a truckload of machine sheets or point to them and suppose that that is quality control. It is not. Information that tells you where you've been is not quality control. In fact, I question whether it does any good at all. I've seen, for example, in a factory, a television screen with every group of 6, 7, or 8 people in the plant to show them the number of defects by type of defect that they made the day before. And that is total nonsense. It's an achievement, an electronic achievement, and it costs lots of money, and it's all done by computer, and some people think that that it's because it's done by computer that therefore it must be right. No, that does nobody any good. That's a waste of money and helps nothing. If you make inquiries, you'll find that the same problems that they have yesterday, they had the year before, that they've had them from the book of Genesis onward. I can tell you that they always will have them, because that is not quality control. By quality control, I mean helping man and machine to do a better job, to turn out better quality, more uniform quality of the kind intended and more of it. In other words, to compete, to increase the capacity of a production line. Statistical methods, incidentally, can do more to increase capacity of production lines than new equipment can offer in many cases, in almost all cases in America. Capacity is not being used. Human effort is not being used. It's being wasted. Material is being wasted. Machine time being wasted. And Americans pay the price for it in higher price, and they've lost a competitive position through higher prices from waste.
Dr. Deming, let's go from the methods and go to the, hopefully, the recipients of these methods, the students. Are they getting adequate training, and if not, why not? These are the students in the universities primarily.
There are exceptions to anything that one may say. For example, I've known Presbyterians that smoke cigarettes. There are some courses in universities, but there are very few. 99 students studying statistics out of 100 studying statistics do not get adequate training. I'd say they don't get any kind of training that would alert them to the problems of industry. Industry is in a far worse condition than most people can realize. I think you have to be a consultant in statistical methods to see how bad, the great need of statistical methods in industry. Industry needs statisticians. The statisticians do not reply. They have nothing to offer. Their training is the wrong kind. They come out as a hazard to industry until they have had a chance to work under a master for a time.
Dr. Deming, in your consulting services, how has the request for your services changed over the last several years? Have you been able to make some assessment of the nature of the clients as well as the volume of the request for your services?
There's certainly an upsurge of interest. I think the film that NBC put on created interest. As I say, I'm afraid that a lot of the interest is hope for quick results. Come spend a day with us. Do for us what you did for Japan. They think that it's all very simple. Could I answer further?
That's fine. Sure.
Well, Dr. Deming, what's the secret to your long, productive, and apparently very challenging career?
I didn't hear. What is
the secret to your long, so very productive and challenging career?
Well, I don't know about your adjectives, but I'd say it is a very exciting career, yes. And I look forward to many more days of it. Thank you very much. I have no secret except continual work and enjoyment of seeing results and meeting such very wonderful people. A lot of American industry is working hard, by which I mean the top management is working hard on what they must do. They know what they must do, and they are hard at it. They're wonderful people, a lot of fine people in American management, and I have the privilege of working with them. I don't work with any other kind.
Dr. Deming, what do you see as the future of all this in terms of American industry?
I see a long pull. 10, 20 years, it may be 30 years before Americans may have confidence that American products are competitive and holding their own. Going to be a long pull. It'll ride along with the improvement in the teaching of statistics. American industry cannot advance faster than the teaching of statistics advances. There are lots of advances, by the way, in the teaching of statistics. For example, the University of Tennessee is instituting, beginning in September, I believe, 3 weeks of intensive learning. A man will come for a week, go back to his company for a month, come back for a week, go back to his company for a month, come back for a week. And as I understand it, they will take only 40 people. I may be wrong about this. I perhaps should not say it for general distribution because it's so simple to write to the university and get a folder that has all the information. In fact, I have it in my briefcase, but that is not at this table. Education is improving, but think of the pitifully small number of people that they can accommodate. One company that I work with must train 50,000 people, and another one must train 50,000 people. Suppose that it's only 20 people that you need to train. How long will it take? How long will it take to train 50,000 people? A long time. Where are you going to get the teachers? Think of the problems ahead. Think of the problems of training the managers of purchasing. How long will that take? As I said, 5 years on an emergency basis. The matter of training must be totally rewritten. The books on economics have to be rewritten. The economists may find out in 10 years that we're in a new economic age. Maybe government agencies will find it out in 15 or 20 years.
Do you feel for the statistics education program, the interchange of the university with industry is the right direction that we should be going?
The only possible solution, yes. But even that won't work unless it's done right. Whom will you get from industry? There's no point in getting someone from industry to teach in a university if he has just the same old thing to offer or nothing to offer.
Dr. Deming, what do you think in this regard about setting up programs of internships, for example, where students may work during the summer with a company who has a statistician and they work with him and try to get a feel for the problems of industry?
Those would be good, I think. There may be such programs now. Maybe not with industry, but with government, and I think Dr. Eisenhart can tell you about those. I cannot. The idea is good. How to make it work, I don't know. Years ago, when I was in charge of statistical courses at the graduate school in the Department of Agriculture, we started an internship program for people to learn in industry and in the government. And there was not one single applicant. Nothing happened. Absolutely zero. Absolute zero. So I don't want to sit here and tell you that that's a great idea. The idea is great. Whether it will work, how to make it work, I think is the problem. How to make it work. The idea is good. The problem is how to make it work. I think that it can be made to work. The American Statistical Association could perform a great service along that line, if it's the right line. I mean, we'd have to do some testing and trial, but the American Statistical Association has responsibilities, challenges, and opportunities that no other organization has. What are they going to do about it?
Dr. Deming,
Not everybody has all the answers.
I hear your message. I think I personally feel also that these traineeships, possibly fellowships, might be the answer if they're handled correctly.
I don't doubt it. Could be.
Dr. Deming, we've read in the popular literature a lot about Japanese quality control circles. What makes them work? Why are they so successful in Japan? And is there a carryover of that concept to U.S. industry, perhaps?
I'm so glad that you asked that question. Remember this, that the Oriental way of working is to work as a group. A man is happy because he contributes most to the group. The unhappiest man in the group is the one that feels he is not contributing his share to the group. So, you see, you have a totally different situation. Everybody in a group will help anybody in the group to do his work, to improve his work. It will help him to find what it is in the group that he can do best. They'll make sure that he does the work in the group that he can do best. Now, the group can observe that the management is doing their job. That is, the management has taken on their responsibilities. Whether successful or not makes no difference. It is obvious to everybody in the company that the management is putting forth their efforts to improve the system continually in all of my 14 points, and to make it possible for people to work better, for everybody in the plant to work better, and I might say with the aid of statistical methods. Now, when management does their part, then people become creative. There was never any problem in Japan about this because the management always tried to do their part. It was obvious. The group in Japan is the way people work. Put it another way, people work as a group. Now, if you ask the question, can that idea carry over? It'll carry over in companies in America where it is obvious that the management is trying to do their part. Whether successful or not is not so important as the obvious attempt to try to improve the system, to try to keep equipment in order, to try to put out a product or service that will sell, to get the right materials, to be interested in the materials, to make sure that materials are suited to the job, to make sure that equipment reported out of order is corrected. When people see that the management is trying, whether successful or not, then people will become creative. Then they might even work in groups here. I do not know. A lot of companies are starting QC circles in this country. My guess is that nearly all of them will be dumped in 3 years. I give them a lifespan of 3 years at the most. They'll be dumped because they didn't work. And people will say that quality control, we tried quality control here and it didn't work. When the fact is they made no attempt at quality control. Let me put it another way, Dr. McDonald. QC circles will not work anywhere in the absence of quality control. And don't let anyone tell you that QC circles are quality control. They are not. They can help, but not unless there is quality control.
Thank you.
Well, Dr. Deming, it seems to me that some facets of American industry are getting your message, but it seems to me that maybe you also have to sort of give a message to deans at universities and places like that, because when I talk to university professors about giving the students more experience with a real problem and get experience with how real data are as they evolve in practice, the answer I get is, that's a good idea, but a student can't do very many problems that way, and the dean will think he hasn't done anything at all. In other words, you can only do 1 or 2 real problems per semester, whereas you can do hundreds of textbook ones.
I would prefer that the man do 1 problem in the semester and omit the problems in the textbook, because nearly every one of them is wrong and leads people to think wrong, to solve the wrong problem, to solve non-existent problems, or problems that are purely asinine, positively asinine, like testing to find out if two treatments are different. Now, anybody knows before he starts that they are different. The only question is, how different are they? And a lot more questions that are not in the textbooks. For example, the engineers in design decide that a certain part in a machine would perform better if it were made of steel rather than plastic. Now there are problems. The part is going to cost more. There are problems of manufacture. And the question is never whether the machines will work better with the steel part. The question is how much better? What will be the problems of introducing a steel part? Will the improved performance be worth the additional cost? Those are the problems, and they will not be answered by the analysis of variance or by a t-test, but by better methods. And statisticians on the job are using better methods all the time. A lot of interesting things come up when you tackle that problem. If, for example, you were able to place this new part made of steel in a sample of machines, possibly on your own premises, and some planted around in customers' premises, examine the mean time to failure with the plastic part and the mean time to failure with the steel part after replacement. Let's suppose that in one machine, the steel part, when you look at the results, did not perform as well. The mean time to failure is shorter than it was with the plastic part. Well, I would throw such data away. That would only indicate that the part wasn't put in right, there was something wrong with the machine in the first place, or somebody made it wrong by putting the part in, that it maybe put the part in right, but ruined some other part of the machine, screwed it back together wrong. And those are problems that you simply don't see. You learn about rejection of observations, but the problem of how to look at data as a prediction to try to help somebody to improve performance is we'll have to develop in statistical teaching.
I think our time for this program has almost elapsed, and before it escapes us completely, I'd like to extend a special thanks to Dr. Eisenhart, Dr. Nelson, Dr. Leone, and a very special thanks to you, Dr. Deming, for sharing your views and insights on the history and development and the current state of statistical quality control. Thank you.
Thank you, and my pleasure.